All right, guys, welcome back to this video. Hope you just watched the last one because we're going to continue right where we left off. Because if you didn't see it, go watch the last one. I'll put it in the link in the description, I guess. But we're going to go ahead and put this into any base. So remember, this is in base 10. This is to find the nth digit of the Champernowne Constant. We're given when we know what m is and we know what n is, right? So now how do we do this in any other base? Well, let's go ahead, look at this in base 8 or the octal system. Go ahead and do that. I don't want to write out letters and start doing hexadecimal and add all that sort of stuff. It's a little bit confusing for me. It works there. I've tried it. It works there for sure. But we have numbers for base 8. So let's go ahead and do that. So we have 0.1, 2, 3, 4, 5, on and on. But now we get up to 7, right? So this is base 8. Then it goes to 10, 11, 12, 13, 14, 15, 16, 17, 20, and so on, right? And we're going to go on again. And we're going to go up to, it's going to be up to 70. Let's just do 75, 76, 77, and then I'll wrap around to 100, right? That's what that's going to look like in octal. Because it's base 8, and that'll overflow up and up and up. It'll give you 100, right? So now we need to figure out the number of digits that we have, right? Okay, so first thing we see here, the single digit numbers, well, there's 7 there. Whoa, crazy. 7, same in base 8 as in base 10, it's 7. Now what we have here, for those 2-digit numbers, we have 70. It's not 70 in how do I say this? It's not 70 in base 10. It's the 70 in the octal system, right? So we have the 70, and we'll go ahead and explain that real quick. Is we have these 7 right here, right? Well, we have similar in the way as it was in the in decimal. We had 9, then we had 90, then we had 999, all that stuff, right? Well, not 99. You get what I'm saying. This 70 right here comes from the fact that we have the 8 right here up to there, right? And that's a 10 in octal. And then we have 7 sets of that 10. Remember, that 10 is equal to 8, so this number is actually equal to 56. So it's 7 times 8 is 56. That's 56 in octal, right? So it still follows the same pattern, though. So it's a 70. And then we have 100 here. And then it goes, and we're going to go ahead and drop that box down there real quick. This is all the base 10 stuff. We'll erase it here in a second. That goes 101. And we're just going to go dot, dot, dot for now. And that goes up to, let's just say, 776, 777. Right? And that right up there is going to be 700. That is in octal, though. Remember, that is in octal. It's not the same. So we're going to go ahead and do same thing we did the last time we were doing it in base 10. Go ahead and spread this out. 7 times 10 to the 0. Right? And that gives us our number of terms. That's 7 times 10 to the 1. And that's 7 times 10 squared. Now remember, this 10 here is really an 8. So basically we have 7 times 8 here, which is 56. Then we have 7 times 64, which off the top of my head, let's see. I'm not going to do that in my head right now. I'm not good at basic math or anything like that. I'm not really good at math, but I can do this sort of. We have 7 times 10 squared here, and that gives us the number of digits there. And to find the number of digits, we just need to multiply by 2, right? Just go ahead and we multiply the number of digits that are there. So we're going to go ahead and we're going to go 7 times 10 to the 0 times 1, and 7 times 10 to the 1 times 2 times 2. There we go. Then we have 7 times 10 squared times 3, and on and on and on. This pattern holds. It goes up to times 4, times 5, times 6, and all these numbers go up each time. And that's the same in other bases too. So let's go ahead and we'll erase this top section up here. I'll go ahead and rewrite this here in a second. But it's going to be in the form for any sort of base. get rid of that real quick. So let's go ahead and look. Say we were in base 5. Let's do base 5 here real quick. So we have 0.1, 2, 3, 4, and then it's 10, 11, 12, 13, 14, 20, ... You get the picture. Then it goes 53, 54, 55, 100. And then it goes 101, 102, ... And we go up to 5, 5, 4, and then we go 5, 5, 5. And that's what we get right there, right? So that's sort of how that looks in base 5. So if we look right here, total number of terms is 4 there. Total number of terms here, and that one right there, well, that's just 40. Remember, that is in base 5. It's not the same because the 10 that we're going to pull out here in a second is equal to 5. So it's going to be basically 4 times 5, which is there's going to be 20 digits here. Well, not 20 digits, 20 terms here, right? 20 terms. So we're going to have, well, the 400 there. We're just going to come, well, not going to come down. We're going to go ahead and go 4 times 10 to the 0, like we did down here, right? We're going to go ahead and go 4 times 10 to the first. We're going to do 4 times 10 squared, right? Same basic thing. Remember, that's a 5. That's 25 times 4. There's 100 digits here. Well, not 100 digits. There's 100 terms here. Then we're going to go ahead and multiply these by each of the number of digits. So 4 times 10 to the 0 times 1. 4 times 10 to the 0, 1. 10 to the 1, sorry. Times 2. And 4 times 10 squared times 3. Well, that gives us, say, that one's actually a 25. That one is a 4. That gives 100 times 3, 300 digits in this one. What's that one there? That's 5, 20. That's 40 there. That's 4 there, right? So this pattern holds for every single base. There's always going to be that base. So the base system is, so this is base 5. And we're going to let B be our base. We're going to have, so the Champernowne constant with C base, the Champernowne constant base B will give us the base of the number, right? So that's going to be another variable we have in the equation here in a second. We can see these all follow the same sort of pattern. And basically, they're the exact same as base 10, except being multiplied by a different number out front, right? So all we need to do to rewrite the form, and the table holds, you can go ahead and write that out. I encourage you to try it for yourself. I don't have a lot of time on my videos because it's free software. I'll figure that out eventually. Basically, what else we have here is, so let me go ahead and grab my paper. So similar to that, we have 10 to the m minus 1, right? And that gives us our range of numbers as before. And remember, this 10 is going to be in, oh boy, this is a bad marker. Yeah, that works fine. 10 to the m minus 1, right? And that's going to be in whatever base we're using. That's the 10 in whatever base. So we're going to use that. And then we're going to multiply that. Well, for the function, we're going to actually add. Sorry. I like the floor function notation, remember? Then we have n minus b minus 1 times the sum up to m from s equals 1 of m, well, not m, sorry, s times 10 to the s minus 1 floor over m plus 1. That's our form for it right here. This b minus 1 is just the, just like how it was in base 10, we put a 10, then 10 minus 1, so it was a 9 out front. And it's the exact same formula. And then we also have the mod 1, which will give us our position anywhere else. So we have n minus b minus 1 times the sum from s equals 1 to m of s times 10 to the s minus 1. All of that mod m plus 1. That gives us our remainder. All right, that's how you do it in other bases. Thank you so much for watching, and I'm just out of time. Talk to you later.